Welcome back. This is the most important lesson in this section in my opinion, right? Because we are going to summarize the pros and the cons of the decision tree. So this is a summary for the whole algorithm, and based on this you can decide if you are going to use this algorithm for your project or not, right? So let's start with the pros. First, the decision tree is easy to interpret and to visualize. We saw in the KNN it was very easy to interpret, right? But it was not that easy to visualize. Now, with the decision tree, it's very intuitive and very easy to visualize, and we can understand everything from just looking at the decision tree graph. So this was the first pro for decision tree. The second pro for the decision tree is that it has no assumption about the distribution of the data, just like the KNN. Because it's a non-parametric model, we didn't really introduce any parameters when we talked about the decision tree, right? We just introduced hyperparameters, which are found in any machine learning algorithm, but for the parameters, we didn't really discuss any, because we don't really have any. So the decision tree is a non-parametric model. So whatever the distribution of the data, it will fit this data. And it can easily capture non-linear patterns. So it's not only a linear classifier or a linear regressor, it's actually used for capturing non-linear patterns, and this is very important in many problems, right? Because most problems are actually non-linear. Now, more than that, it requires fewer data pre-processing from the user. For example, there is no need to normalize the columns, right? In the KNN, we needed to normalize the columns, right? Otherwise, we will have a very low performance for the KNN. While on the other hand, when we are looking at decision tree, we actually fit the decision tree using missing values, using corrupted data, using question marks, and so on. And even though the decision tree works just fine, right? So the data pre-processing is not necessary, or it's not required as much as in other algorithms, right? So this does not really mean that you shouldn't really use data pre-processing or perform data pre-processing. You should perform data pre-processing, and you should perform it correctly, right? But this means that if you don't have the experience or have the time for performing enough pre-processing, then the decision tree is the best algorithm to choose. And it can also be used for feature engineering. So it can be used for predicting the missing values, and it can be used for variable selection or for feature selection. And we saw this when we plotted the features importance, right? We used the feature importances we got from sklearn, or even from our own implementation if we did it, to know what are the most important features, and maybe based on this we can drop the rest of the features or some of the rest of the features. Okay, and finally, it has no problem whether the input and the outputs are binary, categorical, or continuous. So if we have a binary input or a binary output, the decision tree will work. If we have a categorical input or output, it will also work. Continuous, it will also work, right? In the sklearn implementation, we had a problem, but this is a problem in the sklearn implementation. But in our own implementation, we handled all scenarios, right? So this is the pros of the decision tree. As we can see, it's very powerful. Let's now look at the cons of the decision tree. Of course, the first problem is that it's sensitive to noisy data. So if we have noisy data or outliers, it can overfit this noisy data or this noisy outliers or this corrupted data, right? There is no sanity checking in the decision tree, right? Whatever you give it, it will trust it, right? And the second problem with the decision tree is that the small variations or variance in the data can result in a different decision tree, a completely different decision tree, right? Because it's a non-parametric model. So whatever data you give it, then it will try to fit this data. But if we introduced a very small variation in this data, then we will have a completely different decision tree, right? And this will be reduced by ensample learning ensemble learning is bagging and boosting algorithms, which we are going to discuss in the next section. Okay, and the third problem with decision trees is that they are biased with imbalanced datasets, right? So if we have an imbalanced dataset, then we might have a problem, right? The decision tree itself will be imbalanced, and so the outputs will not be really representative of the dataset, and the accuracy will not be a good metric, right? It's recommended, in order to solve this problem, or solve it partially even, to try to balance the dataset as much as possible, or we can try the class weight in the sklearn library, right? And as we know, decision tree is a greedy algorithm, right? So what it means, it's a greedy algorithm. It will search for the best solution right now. It will not really look at the optimal solution. So this is not really that much of a problem, because almost all the machine learning algorithms are greedy algorithms, right? So they will not find an optimal solution. There is no guarantee that they are going to find the optimal solution, but they are trying their best. But I just wanted to mention this here because some of the machine learning algorithms are actually optimal, right? But they will take much longer, and they will have their own share of problems, right? Finally, the most important problem, or the most challenging problem in the decision tree, is that as the branching goes deeper, so as we increase the branching or increase the depth, you will get exponentially less data, and at the same time the running time for the algorithm will increase exponentially. So this is a very serious problem with the decision tree, and we solve these problems in different ways. We solve them by using ensemble learning. We solve them by trying to pre-process the data to avoid noisy data and outliers, and we try to use pruning, pre-pruning, and most pruning. Okay, so these are the pros and the cons of the decision tree. Now, in the next lesson, we will have an overview about the project. So this is a project on the decision tree, a hands-on project, so you can understand everything we discussed in this section and more. So let's go.